Welcome to this tutorial, which is going to address the amount of something, particularly a solid, that we would have to add to a solution for a precipitate to just begin to form. You may remember the previous tutorial had a question like this, where we were trying to establish, based on the Qsp and the Ksp, whether or not a precipitate would be formed when we mix two solutions together. In this particular case, what we're going to do is we are going to try and establish what is the minimum amount of a solid that we could add to a solution before a precipitate would just begin to form. So you can see how the question is a little bit different this time around. We're going to use the same substances. In fact, we're even going to use the same volume and concentration of the sodium fluoride. But you will notice that we are adding a solid to our sodium fluoride here. So our overall volume of this particular reaction mixture isn't going to change. So that actually makes our calculations a lot easier, or at least we're going to make the assumption that the addition of the calcium nitrate solid is not going to impact our volume all that much. So what we are going to do is we're going to start right from this point. So right now it's not really any different than the question that we were doing previously. You can see that I have the balanced chemical equation there. You can see that I have our equilibrium equation. Remember, we're dealing with the precipitate here. And from the equilibrium equation, I can derive the Qsp expression. Now, in fact, we don't need the Qsp expression, or another way we can approach this is that the Qsp is going to be equal to the Ksp. That is, we want a precipitate to just begin to form. So if that's the case, then we want to have the concentration of the calcium ions and the fluoride ions squared equal to the solubility product constant. So we know at this point what the Ksp is going to be. Now what we have to do is try and establish what these two concentrations are. Now, since we're trying to figure out the amount of the calcium nitrate that we're going to have to add, it is the calcium ion concentration that we are trying to figure out here. So this is actually going to be our unknown that we're trying to solve for. So in terms of the fluoride concentration, we have to remember there that the fluoride ion concentration actually isn't going to differ all that much because our volume doesn't change. So the concentration of the fluoride ion is going to be equal to the concentration of the sodium fluoride initially, because this sodium fluoride is going to dissociate in a 1-to-1 ratio with the fluoride ion. So since we know the concentration of the sodium fluoride is 1.0 times 10 to the negative 4 moles per liter, then it stands to reason that we know the concentration of the fluoride ion in this particular reaction mixture, because again, we're going to make the assumption that the addition of the calcium nitrate doesn't change our volume of our reaction mixture. So in that case, we know what the concentration of the fluoride ion is. It's 1.0 times 10 to the negative 4. I'm going to exclude the units here because we are using Ksp, and of course we have to square this value. So again, we don't really have to do too many preliminary calculations here to figure out concentrations because we haven't changed the volume appreciably by adding these two things together. So I'm going to go through now and solve for the concentration of the calcium ion by rearranging this, and in doing so we are going to get the Ksp divided by the concentration of the fluoride ion squared, and if we do that we get a value of 3.2 times 10 to the negative 3. Now because this is a concentration, I am going to put my unit in. So what this tells us is this is the concentration of calcium ions that we would need in order for a precipitate to just begin to form, assuming we had a concentration of 1.0 times 10 to the negative 4 of the fluoride ions in this mixture as well. But the question doesn't ask us for the concentration, the question asks us what mass of the solid, or what amount of the solid in grams or milligrams are we going to need for this precipitate to just begin to form, or what would be the maximum amount that we could add before this precipitate would just begin to form. So what we have to do now is understand that this is concentration, and that if ultimately we want to figure out mass, we're going to have to first figure out the number of moles. But what we also need to understand is that the number of moles of the calcium ion is going to be equal to the number of moles of the calcium nitrate that we are going to add. So we have to kind of think backwards a little bit. We're adding calcium nitrate, a solid of calcium nitrate, to this. Calcium nitrate, once it's added to the solution, is readily soluble, and so it's going to dissociate in a 1-to-1 ratio. So whatever number of moles of calcium nitrate I need, it's going to be equal to the number of moles of calcium, or vice versa, because again, they're going to dissociate in a 1-to-1 ratio once we add the source of the calcium ions. And in this case, it's calcium nitrate. So the formula is well known to us. It's concentration times volume. Our concentration was just determined as 3.2 times 10 to the negative 3 moles per liter. The volume of our reaction mixture in this case is just the volume of the original sodium fluoride solution because that's the only volume that we have. We're assuming again that the addition of the solid isn't appreciably affecting our volume. So you will notice that our units cancel out here and leave us with the value that we are looking for here, in this case moles. So we get a value of 6.5 times 10 to the negative 5 moles. So we're almost there now. All we need to do at this point is find the mass. And again, this is a relationship that's well known to us. The mass is equal to the number of moles times the molar mass. In this case, 6.4 times 10 to the negative 5 moles. We are going to be using the molar mass of the calcium nitrate because that's the solid that we're adding. We can't just add calcium ions. Calcium ions can't be added in ionic form. They have to be added as part of a soluble salt. And in this case, our soluble salt is the calcium nitrate. The molar mass for calcium nitrate approximately is 164.1 grams per mole. Now the number actually is a little bit bigger than the value that's shown there. That is, there are numbers past or to the right of the 5. So we do have to round up in this scenario, which is going to give us a value of 0.011, or if we're converting into milligrams, which probably would be acceptable here, we would get a value of approximately 11 milligrams. So this informs us now that the minimum amount of calcium nitrate that we would have to add to this concentration of this volume of sodium fluoride at this particular temperature in order for a precipitate to just begin to form would be 11 milligrams. Alternatively, if we didn't want a precipitate to form, the maximum amount of calcium nitrate that we could add to a solution of sodium fluoride of this particular concentration and this volume at this particular temperature would be 11 milligrams. So hopefully after watching this, you have a little bit of a better understanding as to how we can use QSP and its relation to KSP and our understanding of what solubility equilibria is, that is, what the value of KSP actually represents, in order for us to determine or evaluate the maximum amount of a particular substance we would have to add to a solution in order for a precipitate to just begin to form. Thanks for watching.